presenter is George Spackman from the University of Nottingham.
Hi, I'm George. I'm studying optimization of 3D woven T-joints. I'm a final year PhD student at the University of Nottingham. So previous work at the university showed that changing the weaving pattern of 3D woven T-joints can produce different failure properties, and has improved upon the 2D laminates. This is specifically under the tensile pull-off test. So this is done using experimental tests and then followed up using numerical modeling and finite element analysis. So what we want to be able to do is to generate those models automatically to use in an optimization similar to what Mikhail was just talking about. So from the weave pattern, we can produce these flat woven models using TextGen. And we need to determine the order that these wefts interlace in order to be able to fully simulate the models. So if we know the direction of the beating, as shown by these arrows on this model below, and the order of the weft insertion, then we can know the order in which these yarns wrap around each other. And we can produce these models automatically, and we get all the information from the weaving pattern up here in the top left. So the process of model generation is that a Python script using the TextGen functions produces this flat woven model. And so some work still needs to be done to be able to finally produce a good geometry for finite element analysis. So first, nodes are needed to shape the weft yarns around the warp yarns, as you can see here. And again, more nodes are needed at the midsection and moved into place according to the weft ordering information we've gained in the previous from the previous slide, and also the way these yarns nest within each other has been taken from CT data. Then transformations of the nodes are applied and are able to be opened up to transform into the net shape of a T-joint. So here are some example models of T-joint weaves that we've automatically generated using this process. So each of these has 10 wefts and 9 warps and 6 warp stacks. So as you can see, they have varying levels of crossover or not, as the case may be, and varying cases where the yarns stay parallel to each other as they go around the bifurcation area. So the aim is to use these, as I said, in that optimization process that Mikhail was talking about. So they need to be meshed using the voxel mesh. Some tensile pull-off tests will be simulated using Abacus. And so the aim is to be able to find optimal configuration of T-joint weaves for resisting delamination.